Hey everyone. Today we're going to talk about something that's, well, it's kind of the invisible engine behind almost everything we do online. It's called the virtual machine. And yeah, it powers the cloud, it can power stuff on your own computer, it's everywhere. So let's dive in and see how this whole thing works. It all really boils down to this one simple but kind of mind-bending question. What if you could take one single physical computer and somehow slice it up so it acts like a whole bunch of different, completely separate computers? That's not just a weird thought experiment. It's the exact problem that virtualization set out to solve.
And the answer, of course, is the virtual machine, or just VM. So what is it? Well, it's not a physical box you can touch. It's a complete computer, the whole shebang that exists entirely as code. It's got its own pretend CPU, its own memory, its own hard drive, and its own operating system, all bundled up in a neat little software package that's totally isolated from everything else. Okay, but how? How does one physical machine manage all of these digital doppelgangers without going crazy? Well, it needs a special piece of software, kind of like a traffic cop for all the computer's resources. And that piece of software is called the hypervisor. This thing is the real magic behind virtualization.
Here's a great way to think about it. Picture the hypervisor as the manager of a hotel. The physical server is the hotel building itself. Each virtual machine, that's a guest room. The hypervisor is the one managing all the building's resources, the power, the water, the space, and it carefully gives a piece of those resources to each guest. And, super importantly, it makes sure that what happens in one room doesn't affect any of the others. But of course, it's not quite that simple. There are two main flavors of hypervisor. First, you got type 1, which we call bare metal. This is the heavy-duty stuff. It runs directly on the computer hardware, no other operating system needed. It's super fast, super secure, and it's what you'll find running in big data centers and cloud providers. Then you have type 2. This kind runs just like a regular app on top of an OS you already have, like Windows or Mac OS. It's not as fast or secure, but it's incredibly handy for developers, or if you just want to try out Linux on your laptop without messing anything up. This whole idea of virtualization, it isn't new. Not at all. In fact, if you look back at its history, you see this really fascinating pattern where software keeps pushing hardware to get better and better. So, way back in the 1960s, you had these giant, crazy expensive mainframe computers. IBM figured out an early form of virtualization just so more than one person could use the machine at the same time. The idea kind of went dormant for a while, but then, in the late 90s, a new problem popped up. The standard computer chips in everyone's PCs, the x86 chips, just weren't designed for this stuff. So, a company you've probably heard of, VMware, came up with this brilliant software trick to make it work anyway. And it worked so well that it created this huge new market. And what happened next? By around 2005, the chipmakers themselves, like Intel and AMD, started building virtualization support right into the hardware. It's this awesome cycle. Software solves a problem, creates demand, and then the hardware evolves to make the software even faster. So cool. And that brings us to today. The world of computing infrastructure is, well, it's a lot more crowded now, right? We talk about VMs, sure, but we also hear all this buzz about containers and serverless. So where exactly do virtual machines fit into this whole modern picture? Let's start with the big one, containers. If you remember one thing from this, let it be this. A virtual machine virtualizes the hardware. That means it needs its own full-blown operating system to run inside it. A container, on the other hand, just virtualizes the operating system itself. It shares the main core, the kernel, of the host machine's OS. That's why containers are so much lighter and can start up in a blink. I absolutely love this analogy because it just makes it all click. A VM is like a standalone house. It's completely isolated. It's got its own plumbing, its own electrical, its own foundation, total privacy. Containers are more like apartments in a big building. They're way faster and more efficient to build because they all share the building's main foundation and utilities. You get a little less isolation, but a whole lot more speed and efficiency. So you can really think of all our modern options on a kind of spectrum. On one end, you have bare metal, the raw physical server. You have absolute control over everything, but wow, it is a ton of work. On the complete other end, you have serverless. You just write some code, upload it, and the cloud provider handles literally everything else. It's maximum agility, but you give up a lot of control. And where are virtual machines? Right there in that sweet spot in the middle, giving you this amazing balance of flexibility and control. So this leads us to the big practical question. With all these choices, which one should you actually use? And the real answer is there's no single best one. It's all about picking the right tool for the specific job you're trying to get done. Let's break it down really quick. If you need raw, uncompromised power for something like a massive database or high-performance computing, you go bare metal. If you're building modern apps designed for speed and scale, think microservices. Containers are your best friend. For tiny, quick tasks that only run once in a while, serverless is perfect because you only pay for the split second it's running. But for that huge middle ground of general-purpose applications, the flexible, reliable, isolated workhorse is, you guessed it, the virtual machine. And look, if there is one thing I really want you to take away from all this, it's this. VMs are not obsolete. Not even close. Just because we have containers and serverless now doesn't mean VMs are going away. They're still the foundation, that powerful and flexible middle ground that so much of the cloud is built on. In fact, a lot of the time, people run containers inside of virtual machines to get the best of both worlds. So there you have it. We went from a simple idea of making one computer act like many, all the way to the fundamental building block of our entire digital world. The virtual machine is basically the blueprint that makes the cloud possible. So now that you get it, the only question left is, what are you going to build with it?